Welcome to my YouTube channel. Today I'm gonna do my best to learn you binary. So let's begin. Every character has a specific number, and they are the same as the alphabet. I will only learn you the alphabet today, but if you want a more specialized video in special characters, I can make that later. But today we're gonna specialize in the alphabet. So, it needs to be 8 zeros once to work in the code, so also called 8-bit or 1 byte. This is 2 bits and won't work because it's 0, 1. We need 8 bits, so 1, 2, 3, 4, 5, 6, 7, 8. And this will work. This will give us an uppercase A, because this is 1 and up here. And how to know it's an uppercase or lowercase character? Well, a lowercase character starts with 0, 1, 1, and an uppercase starts with 0, 1, 0. And if we look at the code before, we see 0, 1, 0, which tells us that it's an uppercase character. How to make a number to binary? Well, first we need to know that a floating number is 1 and a whole number is 0. I'm gonna talk about why I'm talking about floating and whole numbers very soon. But what if we want to make R, which is the 18th character in the alphabet? Well, first we take 18 divided by 2, which is equal to 9, and it's a whole number, so it's 0 in the code. Then we take 9 divided by 2, which is equal to 4.5, which is a floating number and is therefore equal to 1. We round it down and take 4 divided by 2, which is equal to 2, which is a whole number, which is equal to 0. Then we take 2 divided by 2, which is equal to 1, which is a whole number, which is equal to 0. We take 1 divided by 2, which is equal to 0.5, which is a floating number, which is equal to 1. We write the code from bottom to top. So this is 18. So 1 starts first, then 0, 0, which we see here, then 1, which we see there, and 0 again. If you want to count them, this is equal to 1. If this is a 1, it's 1. This is a 2, this is 4, this is a 8, this is a 16 worth. So if we want to read this is a 2 and 16, which is 18. If it would have been these, if it would have been these two, 1, 1, 0, 0, 0, it would have been 1 plus 2, which is 3, which is equal to C. If it would have been this, this, and this, it would have been 1 plus 2 equals to 3, plus 4, which is equal to 7, which is G. I hope you understand. Well, I'm gonna explain this. So we take this code and rewrite this here, and here you can see 0, 1, 0 equals to uppercase character, and this explains that it's an R, and this explains what case the character is in. So it's 1, 0, 0, it's lowercase r. And this will be the same. So yeah, let's go to the next one. But what if we wanted to write a number which doesn't give us 8 bits directly? Well, what if we take d? We do the same. 4 divided by 2 equals to 2, and it's a whole number, so it's 0. We take 2 divided by 2, which is equal to 1, which is a whole number. And then we take 1 divided by 2, which is equal to 0.5, which is a floating number, and is equal to 1. But this is only 3 bits, not 5 bits, as we needed before. So we get 3, before we got 5. We first write the start, which case we want. In this case we want uppercase, and we see that 2 is lost, and we only get 6 bits, and therefore we just add 2 zeros in between those two, and this will give us an uppercase D. So thanks for watching, and bye.